Welcome to the debate. So this year, global enterprise cloud spend is projected to hit $1.03 trillion.
Trillion, with a T.
Right, with a T. And out of that staggering number, about $298 billion is going straight into the incinerator. It's just wasted.
Yeah, it's brutal.
It is. That's a 29% waste rate, which completely reverses years of, financial operations progress. And if that isn't alarming enough, 72% of global companies actually exceeded their allocated cloud budgets last year.
Which is wild.
I mean, only 6% report zero avoidable cloud spending. So we're looking at a massive problem.
Well, those numbers are brutal because they shatter the illusion of control, right? We are looking at a systemic failure where the modern enterprise simply has no idea what it is paying for anymore.
Which is where we fundamentally disagree on the cause. Because looking at the data, I see two distinct but parallel trends. First, a failure to fully automate traditional cloud cost management. And second, a massive blind spot regarding the cost attribution of new AI workloads.
Okay, but
Let me just say, to me, this $298 billion waste crisis is a structural execution speed problem. We are watching a historical repetition of the 8-year adoption lag we saw with traditional cloud tools. The enterprise is just, moving too slowly.
see, I completely disagree. The enterprise is bleeding capital because the underlying physics of cloud computing have changed. This isn't just some execution lag.
Of course it is.
No, look, AI has forced a complete paradigm shift in unit economics. The fundamental time-based mental models that FinOps was built on, they are entirely broken now.
I just don't buy that the model itself is broken. I mean, let's look at the actual operational mechanics of a standard enterprise today. The average FinOps team consists of, 8 to 10 practitioners.
Give or take, sure.
Right, and those 8 to 10 people are tasked with managing over $100 million in annual cloud spend. It is a mathematical impossibility for them to keep pace with continuously changing cloud environments manually.
But they aren't doing it manually. Most $100 million environments have adopted, some form of dashboarding and cost anomaly detection.
Yeah, but dashboarding isn't automation. Running manual FinOps today is like trying to day trade high-frequency stocks using the morning newspaper.
That's a bit of an exaggeration.
It really isn't. By the time a team pulls the costs and usage report, runs an analysis in Excel, realizes an engineer left a cluster of instances running, and writes a recommendation for the engineering team to action, they are operating on a 2019 cadence.
I mean, sure, the reporting lag is real.
Exactly. A programmatic system would have already shut those resources down 10,000 times over. The evidence here is unambiguous. Mature automated programs yield 25 to 30% better monthly savings.
Right, for traditional compute.
Yes, and automating commitment management specifically, like buying and modifying reserved instances and savings plans, that delivers 15 to 35% higher effective savings rates.
Look, I'm not disputing the value of automating the commodity layer.
But organizations aren't doing it. Flexera's acquisition of ProsperOps in January 2026 proved that autonomous commitment management is a necessary commodity layer, yet teams still treat it like some future roadmap item.
Okay, but
If those 8 to 10 practitioners fully automated that commodity layer, they wouldn't be bogged down in operational busy work. They would free up the necessary headcount to tackle the exact AI cost attribution problems you're worried about.
freeing up headcount doesn't matter if the tools those people use are structurally blind to the problem. Let's look at the last mile problem in the exact data you're citing.
All right?
We have mature practitioners who've done exactly what you suggest. They have hit 97% optimization on their AWS cost optimization hub. They captured all the big rocks of waste. And yet, their total waste is still increasing.
Well, they're clearly missing something.
Right, but what? Only 2% of CIOs spent less than projected last year? If this were just an automation lag, those highly mature teams wouldn't be hemorrhaging cash.
So where exactly do you think that cash is bleeding out, if not from missed automation opportunities?
It is bleeding out because platforms optimized for EC2 rightsizing are completely unequipped to govern machine learning inference. GPU-intensive AI workloads now account for 18% of total cloud spend at AI-forward enterprises.
18% is substantial, yes.
Think about that for a second. That is a 4.5 times increase from just 4% in 2023. You can automate your savings plans all day long, but an automated reserved instance purchasing tool has absolutely no idea how to evaluate a machine learning model's inference efficiency.
That implies inference efficiency is just some black box, which it isn't anymore.
It is a fundamentally different economic model. Look, for 15 years, FinOps was about renting time. You pay for an EC2 instance by the hour, regardless of whether it's calculating pi to a billion digits or just sitting completely idle.
Sure, time is predictable.
Exactly. Time-based billing is predictable. But AI inference doesn't rent time, it rents cognitive depth. It bills by the token, the request, and the context length.
Yes, obviously, the billing metric changes from hours to tokens.
It doesn't just change the metric, it changes the entire multiplier of your architecture. Let's say an engineer decides to expand a system prompt from 800 tokens to 4,000 tokens, just to give a model more background context.
Happens all the time.
Right, and that is a 5x cost multiplier on every single API call moving forward. If your application gets hit 1,000,000 times a day, your spend just 5x'd overnight. And here is the kicker.
Go ahead.
That specific variable, context length, is completely invisible to a traditional per-hour utilization dashboard. The CPU utilization might look exactly the same, the memory might look the same, but the bill is 5 times higher.
Which is precisely why the cloud providers have evolved their visibility tools. I mean, if you are listening to this and thinking, oh, my team already uses AWS Cost Explorer, we're fine, you're completely missing the infrastructure updates that just went live.
A dashboard update doesn't fix unit economics.
In January 2026, AWS released a critical update to their data exports specifically for Amazon Bedrock.
Providing more data to a team that doesn't know how to read it doesn't solve a structural issue. It solves the visibility issue, which is the prerequisite to any action. Look, before January 2026, every Bedrock cost hit the enterprise bill as a massive, undifferentiated blob generically labeled usage. It was a total nightmare.
Oh, I remember. Just a big black hole of spend.
Right. You knew you spent $50,000 on AI, but you had absolutely no idea if it was for an internal chatbot or a, customer-facing recommendation engine. But now, AWS provides operation-level granularity.
Granularity has its limits.
Let me finish. You can literally pull line items for invoke model inference and invoke model streaming inference. We finally have a taxonomy.
A taxonomy that breaks at enterprise scale.
How does it break?
If teams implement application inference profiles and strict cost allocation tags, they can establish rigorous baselines for cost per use case.
But they can't.
The reason mature teams are struggling with that 18% AI spend isn't because token-based economics are impossible to govern. It's because they simply haven't turned on the governance infrastructure that AWS just handed them. They are treating 2026 infrastructure with 2023 visibility.
Let's talk about the mechanics of those application inference profiles because the material points out a massive technical ceiling. AWS enforces a limit of approximately 1,000 profiles per account per region.
I mean, 1,000 profiles is a significant amount of granularity.
To a casual observer, sure, but do the math on an enterprise-scale deployment. A minimum viable FinOps structure requires tagging by the specific model, right?
Yeah, of course.
So say you run Claude 3.5 Sonnet, Haku, and maybe a Llama model. That's 3 tags. Then you multiply that by the team owning it. Then you multiply it by the environment, dev, staging, production. Then you multiply it by the specific business use case.
It adds up, but
You burn through 1,000 tags in a matter of weeks.
it's a constraint, yes. But constraints force architectural discipline. You shouldn't have infinite, unmanaged tagging schemas anyway. That's just bad hygiene.
It is an architectural bottleneck. Enterprise-scale deployments are hitting a hard infrastructure ceiling precisely at the moment they attempt to audit their multi-model, multi-environment deployments.
Well,
If the system physically prevents you from tagging beyond a certain limit, your dashboard is fundamentally broken at scale. You are right back to looking at an undifferentiated blob of spend.
I disagree that you're back to a blob. If you define your profile structure early, before you scale, you can operate well within that 1,000 profile ceiling. You aggregate by application, not by individual developer.
But even if you perfectly tag those 1,000 profiles, you are only tracking the waste. You aren't preventing it. And this is where your execution model completely falls apart.
Tracking is the first step to prevention.
You're trying to govern cloud costs operationally, from a dashboard,
After the resources have been provisioned, I am telling you the real bleeding happens at the prompt level. This is the prompt inefficiency tax.
Okay, explain exactly what you mean by that tax in a production environment.
Prompt engineering is inherently a FinOps function now. We aren't just tweaking words for better answers anymore, we are manipulating the core cost driver of the application. AWS data clearly shows that implementing prompt caching can deliver up to a 90% cost reduction for repeated system prompts.
I mean, 90% is staggering. I concede that.
Right. And intelligent routing, basically writing code that dynamically evaluates a user's request and sends simpler tasks to cheaper models instead of routing everything to your most expensive foundational model, that can reduce spend by another 30% without any loss in accuracy.
Sure.
These aren't marginal dashboard adjustments. These are deep structural engineering interventions.
They are engineering interventions, yes, but
Right. So imagine an engineer on a Friday afternoon tweaking a system prompt. They add a 2,000-word block of context to improve the model's tone, push it to production, and go home.
oh boy.
Exactly. Over the weekend, that 5x multiplier we talked about earlier silently blows through the entire monthly IT budget. Can your 8 to 10 person FinOps team sitting in front of their shiny new AWS data exports dashboard catch that prompt inefficiency before it goes to production?
Before production? No, because FinOps is not a code review function.
Exactly. Because if they can't review a prompt for token efficiency before it ships, they are fundamentally powerless to stop the waste. The operational model is dead. FinOps has to evolve from a post-deployment reporting function into a pre-deployment engineering discipline.
Stop right there. You are jumping straight to the engineering solution without acknowledging how we diagnosed the problem in the first place.
The diagnosis is in the code.
But without the foundational visibility provided by those operational tools I'm talking about, your engineering teams won't even know where to implement prompt caching or intelligent routing.
The engineers know where their prompts are.
But they don't know the financial impact of those prompts at scale. You cannot optimize a system if you don't even know which application is driving the bill. To identify that a prompt is inefficient in production, you must first merge the cost and usage report, the CUR, which tells you down to the penny what was spent, with CloudWatch metrics, which tell you your capacity utilization and quota consumption.
But as we just established, standard CloudWatch metrics like CPU utilization don't tell you anything about token efficiency.
Not standard server metrics, no. But looking at the API operation metrics does. Instance utilization is at 30% means absolutely nothing in AI. But if your dashboard shows that the marketing team's inference spend doubled overnight while their application output remained entirely flat, that tells you exactly where a rogue prompt was deployed.
So you're basically relying on a postmortem.
I'm relying on an operational baseline. The operational baseline absolutely must precede the engineering intervention. You can't just tell an enterprise of 5,000 developers to, quote, write better prompts.
Well, you train them.
You have to use the January 2026 visibility tools to find the 5% of applications generating 80% of the token waste. And then you mandate prompt caching.
That assumes the cost behavior of these applications follows some predictable linear pattern that a baseline can actually capture.
Why wouldn't it? If usage goes up, spend goes up. The ratio of tokens to dollars is fixed by the vendor.
Because the workloads themselves are fundamentally changing. We aren't just sending synchronous API calls anymore. We are entering the era of agentic AI workloads, which completely breaks your baseline theory.
You're talking about the rollout of Bedrock Agent Core.
Yes, for anyone deeply embedded in this space, Agent Core is the earthquake. We are no longer dealing with a user typing a question, a model generating an answer, and the transaction ending. Agentic workloads are self-invoking. They asynchronously chain calls across multiple models.
I understand how agents work. They execute multi-step reasoning.
But think about how they execute it and what that does to the unit economics. If a user asks an agent to research a competitor, the agent might secretly spin off 10 different subqueries to a cheat model just to gather data.
Sure.
Then it evaluates that data, realizes it's missing financial context, self-invokes a web scraping tool,
feeds that raw text into an expensive foundational model for sentiment analysis, and loops back.
It is executing the task it was assigned.
But look at the cost. A transaction that looks like a single 1-cent query on your dashboard just spawned a hidden autonomous loop that cost $5.
Okay, that's...
And if the agent is poorly bounded, like if the developer didn't set strict iteration limits, it can get caught in a recursive loop and run indefinitely. Agent Core creates a fundamentally new class of cost surprise.
A baseline would still catch the spike in token volume, though.
But a baseline can't track the causality. Traditional visibility fails here because per hour or even per inference models cannot account for multimodal autonomous chains.
They show the spin.
Your dashboard shows a massive spike in inference cost, but it cannot distinguish between a legitimate, highly complex reasoning task that is delivering massive business value and an agent caught in a recursive loop burning capital on nothing. You cannot baseline autonomy with a static tool.
Look, I think you are underestimating the severity of the market forces that are about to hit us. We don't have time to wait for a perfect pre-deployment agentic engineering framework. The incoming hardware price pass-throughs make establishing these visibility baselines an absolute emergency right now.
Well, the vendor price hikes are definitely going to act as an accelerant.
An accelerant is putting it mildly. Look at the supply chain data. Dell announced 15 to 20% server price increases in late 2025. Lenovo immediately followed suit. OVH is forecasting 5 to 10% increases running through September 2026.
Yeah, it's a crunch.
And historically, hyperscalers like AWS, Azure, and GCP lag behind the hardware providers by about 3 to 6 months.
Meaning they absorb the cost temporarily before passing it right to the tenant.
Exactly, which puts massive cloud price hikes squarely in the Q2 to Q3 2026 window. We are literally months away from this. IDC is currently projecting a 30% rise in underestimated AI infrastructure costs for G1000 organizations by 2027.
That's a huge hit.
So let's bring this back to the baseline. If organizations do not immediately implement the AWS operation level tools to establish a clean, accurate Q1 baseline of their token usage, they will have absolutely no idea what is driving their cost when the Q3 spikes hit.
They'll just see the total bill go up and panic.
They will be entirely blind. When the bill spikes by 30% in August, they won't know if it's because AWS raised the price per 1,000 tokens or because their own developers deployed an inefficient agent core loop. You cannot negotiate with vendors or optimize your architecture if you can't isolate the variables. That is why I maintain this is fundamentally an execution speed problem.
I agree entirely on the urgency of the price pass-throughs. Those Q3 spikes are going to be brutal for anyone caught off guard. But a human baseline tracking old linear prompt usage doesn't protect you from the agentic chaos of Q3.
It protects you from the 18% of cloud spend currently running on standard inference models,
which is rapidly shifting toward agentic workflows. If you are relying on a dashboard to tell you that an agent spent $10,000 over the weekend, you have already lost the $10,000.
So your solution is what? Halt all deployment until every engineer is a certified FinOps practitioner?
My solution is acknowledging reality. No amount of automated EC2 rightsizing will govern the prompt inefficiency tax. No post-deployment dashboard will control the chaotic, self-invoking cost structures of an agent core chain.
But the unit economics are different. The optimization windows are step changes, like a 90% drop from prompt caching, rather than the marginal 2% adjustments we used to hunt for. FinOps isn't a dashboard anymore. If FinOps isn't in the room reviewing prompt token efficiency and agent iteration limits before production, the battle is already lost.
I hear your point on the limitations of post-deployment metrics, I really do. But my stance remains grounded in the history of enterprise behavior. The current $298 billion waste crisis is a failure to execute.
We'll see about that.
We have a rapidly closing 12 to 18-month window to implement tools like autonomous commitment management and AWS's new operation-level visibility. If teams fail to act, treating automated governance as some distant future goal instead of a day-one priority, they are simply repeating the exact same adoption lag we saw in 2018. The tools exist. We just have to turn them on.
Well, while we clearly disagree on whether AI is a continuation of that old automation lag or a complete rupture of the existing economic model, I think we converge entirely on the stakes here.
Yes. Ignoring the token-based reality of AI infrastructure will be absolutely disastrous for any enterprise operating at scale.
Without question. Whether you view it as a failure of execution or a paradigm shift, treating a dynamic 4,000 token cognitive workload like a static, hourly server instance, that is going to drain enterprise budgets faster than anything we've seen in the history of cloud computing.
Absolutely.
The hardware costs are rising, the workloads are gaining autonomy, and the traditional safety nets are fundamentally failing to catch the waste.
There is certainly much more to explore in the source material, particularly regarding how specific vendors are structuring their optimization strategies. But, the shifting relationship between platform engineering teams and AI engineering teams is perhaps the most fascinating aspect of this transition. It forces us to look closely at how the cost architecture of a system dictates the actual software development.
It proves that cost isn't just an output of the system anymore. Cost is a functional parameter of the engineering design itself.
It is a parameter that is changing by the millisecond. The question for 2026 isn't whether the cost dials are spinning. It's whether enterprise leaders realize which machine they are actually trying to control before the system breaks completely.